Welcome to The Explainer. Today, we're digging into a really tough problem in education. How do you prepare someone to teach a subject that, honestly, terrifies them?
So let's just jump right in, shall we? Because the answer here, it's not just for teachers. This could actually change how all of us think about math education. We're talking about a huge challenge. It's more than just teaching formulas. It's about meeting incredibly high standards without crushing the confidence of people who are already walking on eggshells around this subject.
All right, first things first, let's really paint a picture of the problem here. Because for these future elementary school teachers, it's like walking a tightrope.
Okay, so picture this. On one hand, the requirements are huge. We're talking college-level algebra, statistics, all these rigorous state standards. But on the other hand, what are these teacher candidates actually walking in with? Well, a lot of them have serious math anxiety, maybe a weak foundation from way back when they were in school, and they've got just one course, maybe two, to figure it all out. It is a massive squeeze.
So you might be thinking, okay, why not just teach it the old-fashioned way? One subject at a time? Well, it turns out that approach can actually make things a whole lot worse. And this quote, man, it just hits the nail on the head, doesn't it? Teaching these big, complex ideas all by themselves, it's like handing someone a wobbly ladder and telling them to climb a skyscraper. The support they need, it's just not there. Okay, so that's the problem. Now let's talk about the solution. Let's look at a new blueprint for building a much stronger foundation for learning, one that's actually designed to build people up instead of stressing them out. And the solution really is a complete change in perspective. It's called an integrated modeling-based approach. Sounds fancy, right? But all it really means is we stop teaching math as this long, boring list of rules you have to memorize. Instead, we start treating it like what it actually is, a powerful tool for understanding the real world. So remember that shaky ladder? Well, this new method throws it out. Instead, it builds solid scaffolding. It gives students the support they need to reach those high-up, complex ideas, and at the same time, it's actually strengthening their confidence from the ground up. So, what does this scaffolding actually look like in a real classroom? Well, it's not just one magic trick. It's actually a toolkit built on 4 key ideas that all have to work together. And it's really important to see these as a whole system, not just 4 random steps. Everything from how the subjects connect, to the tech they use, all the way to how they approach making a mistake. It all works in concert to turn a classroom from a place of fear into a place of actual, genuine curiosity. All right, key number 1, strategic integration. So, instead of algebra over here and statistics way over there as 2 separate, scary things, this method builds what's called a regression bridge between them. It uses real-world data to show how algebra is actually the language we use to describe patterns in statistics. Suddenly, it's not abstract anymore. It's connected. Okay, on to key number 2, technology. And this one is a total game changer. It fundamentally changes what happens in the classroom. Think about it. In a typical math class, where does all the time and energy go? Like 80% of it is just grinding through calculations by hand. It's slow, it's frustrating, and if you have math anxiety, it's a nightmare. But with this new approach, you flip that completely. You let software do the heavy lifting, the tedious number crunching. And that frees up 80% of the class time for what actually matters: thinking, reasoning, and figuring out what the heck the numbers are trying to tell us. All right, key number 3 is what's called the calculation recipe framework. And this is so clever. It basically reframes algebra. Instead of abstract, scary-looking rules, you start to see expressions as recipes. They have ingredients and steps you can describe in plain English. It makes that very specific, very intimidating math language suddenly feel a lot less foreign. And that brings us to the 4th and final key. And honestly, this might be the most important one of all. Because this isn't just about getting the right answer. This is about completely rebuilding a person's relationship with math. So, how do you build back that confidence? Well, you change the whole game. For one, you start using problems where there isn't just one single right answer. That right there takes away so much of the fear of being wrong. And then, and this is huge, you totally reframe what an error is. It's not a failure. It's a learning opportunity. In fact, it's maybe the best learning opportunity. That's how you build real perseverance. So when you put all these pieces together, what happens? What's the end result? Well, it's way more than just passing a test. We're talking about a complete transformation in how these students see themselves. I mean, look at the journey here.
The goal is to take these future teachers from a state of genuine math phobia, where it's all about fear and just memorizing rules, all the way over to true proficiency, a place where they're confident, where they can think abstractly, and where they actually see a tough problem as an interesting challenge, not a dead end. And all of this really leaves us with one big, powerful question to think about. If we can solve math anxiety for teachers by focusing on connection and support instead of just brute force calculation, could this be the blueprint for fixing it for everyone? Could this change how we all relate to math?